The next thing we have to talk about is independent events, and this is exactly what you would think. Events are independent if the occurrence of either of them does not affect the probability that the others occur. So they don't affect each other, then they are independent, okay? So that's common sense. However, it gets a little tricky with all the math stuff. So if they are independent, then the probability of them both happening should be A times B. How is this rule different than the original rule I gave you? If we go back and look at the original rule, what's a little different about those two?
We're trying to find both of them together in the first one.
Oh, the first one was the given. The second
This one had the given in it. You had to say B given A. Well, if they're independent, then B, it shouldn't matter if A has happened, okay? All you should be able to do is just straight up multiply them, okay? Then you have this method too, which is really the same thing. The probability of A given B is the same thing as probably A, because why? They're independent. What does independent mean? They don't affect each other. So the probability of A, given that B has happened, is the same thing as probability A because they don't affect each other. Or the probability of B given A is the same thing as probability of B. Okay? So let's do a problem and see what that looks like. You have 55% chance of rain, 25% chance of lightning, 55% chance of lightning and rain. Are the two events independent events? Okay? So when you see this question, are they independent? You are multiplying and see what you get. So, what is the chance of rain? 55%. What is the chance of lightning? 20%. Okay, so you multiply those two things. 0.55 times 0.20. What does that give you? What does it give you? 0.11. Okay. Does this equal what they told you up here, a 15% chance of lightning and rain? No. So these are not independent, okay? They're not independent, okay? They're not independent. When you multiplied them, you didn't get the and. You didn't get the and one, okay? All right. This one wants to know, are events B and F independent? Okay, so, but they didn't give us the probabilities. We're going to have to figure them out. All right, B is the event that the selected card has a what? A black symbol. Okay, so look at your cards right here. Here are your cards. How many have a black symbol? 3 out of 6. So the probability of getting a black symbol is 3 out of 6, okay? All right, F is the event that it has a 5. How many have 5s? 2 out of 6, okay? All right, and then we want to do black and 5, okay? How many are black and have a 5 on them? 1 out of 6. Okay. To test to see if they're independent, you're going to multiply. I'm going to multiply these two things. 3 over 6 times 2 over 6. 3 over 6 times 2 over 6. And what are you getting? So when you multiply, did you get the and answer? So that makes the answer yes. Okay, that makes the answer yes. So when you multiply B times F, if it equals B and F, that means it's a yes. When you multiply, if it equals the and one, it's a yes. If it doesn't equal, it is a no. Okay? All right. Are events M and N independent? So I'm going to be multiplying. What does it say the probability of M is? 0.4. What's the probability of N? 0.2. All right. What do you get when you multiply 0.4 and 0.2? Get 0.08. Okay, we have to check and see the and one. Okay, you got to look for the and symbol. In this case, they gave you two. They're trying to confuse you. They gave you the or and the and. Which one are we using? The and. What do they say the and is? 0.08. Okay, so do these match? So the answer is A. Yes. So you can mark out A and B. And one has a plus, one has a multiply. Which one did I say we were doing? We were multiplying. So the answer is D. Okay? Answer is D. All right, last one. Which of the following are independent events? Okay? And this one, unfortunately, we got to do some calculations. All right, a teacher prefers tea. How many teachers prefer tea? 28. 28 prefer tea. Out of how many? So look, if you look in this corner, they have the total, which is 80. Okay. All right, how many teachers teach English? 22 out of 80. Okay. All right, so this was tea, this was English. Now let's go ahead and do tea and English. How many teachers drink tea and teach English? Very good. English and tea is 7 out of 80. Okay? All right, so you multiply these two. You multiply those two. You multiply the two individual events. 28 over 80 times 22 over 80. And hit math, enter, enter. Is it 7 over 80? Does it equal this one? Does it equal 7 over 80? No. So A is not my answer. Okay, hopefully it will be B so we don't have to do so much. Okay, how many teachers prefer coffee? 30 over 80. Okay. How many teach math? 16 over 80, okay? And then let's do coffee and math. How many prefer coffee and math? Very good. Okay. All right, so multiply these two. Multiply those two, 30 over 80 times 16 over 80. Oh, and this is tricky. Is this 3 over 40? Yes. Yeah, so type that one in and make it a fraction. 6 over 80, math, enter, enter. And are you getting the same thing? Yes. Yes, so the answer is B.